Hello students. So in this video we are going to discuss a beautiful concept from chapter cylinder, cone and sphere, mensuration, and we are going to take the concept of melting and recasting. A very important question from the ICSE board point of view. It comes almost every year. So let us understand this. So before we take this question, we need to go through one basic example. This is one example which I give to all my students. That example is of making chocolates. Now, if you have ever made chocolates at your house, at your home, or if you have seen your mom or sister or brother or someone make chocolates, you might be knowing a little bit about it. So let's run through the procedure. So the first thing that people do is they'll get a chocolate slab, which is generally a cuboid in shape, from the market. They'll buy it from the market, and then they'll melt it. They'll heat it so that the chocolate melts. Now let's say we take a container, we put the chocolate slab in it, and we melt it. Now when we melt it, that cuboid shape will turn into liquid chocolate. Now that liquid chocolate is further taken and it is poured into chocolate molds. I'm sure you have seen some chocolate molds. If you have made chocolates, there are some chocolate trays with some shapes. If you know about homemade chocolates, if you have bought it from somewhere, if not made, but at least bought it, you must have seen they always come in different shapes because there are trays available with different shapes. So in the tray, you will pour the mold and that will then be kept in deep freezer, and then you get the frozen chocolates. So what you need to understand, students, is we started with a cuboidal chocolate slab. We ended with, let's say, 20 chocolates, for example. Then here the equation will be that the volume of that chocolate slab, the original solid, will be equal to volume of all the 20 chocolates combined together. So in melting recasting, this is the basic fundamental, that the volume of the original solid will be equal to volume of all the solids formed after recasting. So this is the basic idea that we are going to work on. Obviously, you might be thinking that in practical use, if you have made chocolates, a little chocolate will get wasted. It will maybe stick to the container or it may just spill over. But here in our syllabus, we have simple questions. We will have an assumption that no material is lost while this conversion. So keeping this in mind, let us now take the question. So the question here reads as, a solid cone of height 8 cm and base radius 6 cm is melted and recasted into identical cones, each of height 2 cm and diameter 1 cm. Find the number of cones formed. So the situation is, students, that we are starting with a cone. We are starting with this cone and we are now going to melt this cone and form small cones. So basically the height is given, the radius is given, height is 8, the radius is 6, and now we are going to melt this cone. So let's take a container, we'll put this cone in this container and melt it. So when we melt it, we'll get a liquid. Using this liquid, they are saying that small identical cones are made. So now we are going to make small identical cones. What you have to understand is that originally we started with a big cone and now we are forming small cones. So the volume of that big cone will be equal to volume of all the small cones combined together. So here the equation will be volume of bigger cone is volume of all the n identical cones. Let's call the number of cones as capital N. So further the equation will be volume of the bigger cone is equal to n into volume of one small cone. Do you understand, students? Because the cones are identical, each will have the same volume. So total volume of all the n cones is n into volume of one cone. So here we get the equation, the number of cones n is volume of the big cone divided by the volume of the identical cone. And then you solve that equation and you get the value of n. Now here, students, what I want you to understand is, from the calculation point of view, in melting recasting questions, never ever solve both the parts separately. I repeat, we will not be finding volume of bigger cone separately, we will not be finding volume of the smaller cone separately, and I'll tell you why. When we go ahead with the calculation, you will realize a lot of stuff is going to get cut. So let's go ahead with the calculation. So here, students, volume of the bigger cone. Volume of bigger cone is 1 upon 3 pi r square h. For the cone, the height is 8, radius is 6, so r square will be 6 into 6 and h is 8. Further, for the smaller cone, it's again 1 upon 3 pi r square h. Here the diameter is 1, which means radius is half. So we have r, so 1 by 2 into 1 by 2, and h is 2, so height is 2. So here, students, we will now substitute everything. So n is going to be volume of bigger cone upon smaller cone. Bigger cone is this expression upon the volume of smaller cone is this expression. As I told you, here a lot of stuff is going to get cut. So if you look at this, the 3 gets cut, the pi gets cut, over here we can cut the 2, and the final answer will be 6 into 6 into 8 in the numerator. This 2 will go in the numerator, you multiply, you get the answer. And that is going to be 576. So I hope, students, you understood this concept of melting recasting and you also understood the calculation trick. You will not be solving them separately, we'll just divide them together, cut a lot of stuff, and then the calculation becomes easier. You practice such questions, students, in board exam, it has a good 70 to 80% chance of coming. You should know this type very well. Thank you.